Okay, so first section we're going to look at is 4.2. Okay, so we'll spend today and tomorrow on it. It's called the law of sines. So when we solved triangles a couple weeks ago, every single problem had a 90-degree angle. Right? Always had a right angle. Well, if you don't have a 90-degree angle, that's called an oblique triangle. There's really two categories for oblique triangles. You could have a triangle where all the angles are less than 90. Think of like an example would be an equilateral, 60, 60, 60. That would be called an acute triangle. Or you can have the case where you have one angle that's bigger than 90, right? And that would be an obtuse triangle. How come you couldn't have two angles in a triangle bigger than 90? Corey? Yeah, it would be over 180. So when you're dealing with the kind of triangles we're dealing with, which are flat, all the angles have to add up to 180. And if you're wondering, well, are there any other kind of triangles? Yeah, there's triangles that are not flat. If you think of like the surface of the Earth, and you draw 3 points on that, like the North Pole, Boston, and London, it makes a triangle, but it's on a surface that's curved, so it's more of on a sphere. So that's a little different. With those kind of triangles, angles don't have to add up to 180. They can add up to more than 180. But again, we're dealing with triangles that are flat, okay, flat surface. So when I draw my triangles, it's just to set up a diagram to kind of see what's across from what. First of all, they're not going to be to scale. Okay, that's important. And when I set them up, I'm going to use certain letters for the sides and certain letters for the angles. Does anyone remember from last week the letters we used for the sides of a triangle? Yeah? Yeah, we always used English letters for the sides, A, B, C, and we always used Greek letters for the angles. Well, a couple of these Greek letters are familiar. Okay, alpha is always the angle across from A. And does anyone remember the name of that Greek letter? Beta. Beta is always across from B. And last week, that's all you had to label because this was always 90. You didn't need a name. We just called it the right angle. This week, it's not 90, so we need a name for it. Okay. That symbol is gamma. It kind of looks like a Y a little bit, or like a bird flying off into the sunset. However you want to remember it, that symbol is gamma. So we always want to set it up A across from alpha, B across from beta, C across from gamma. If you want to draw your triangle a different way, you want to put it this way, that's fine. Just make sure A is across from alpha, B across from beta, C across from gamma. Put it however you want. So there's always 6 pieces of information you have to find. There's 3 sides, 3 angles. Out of the 6, I have to give you 3. Okay, you can't solve one of these unless I start you off with 3 pieces of information. And depending which 3 I give you is going to control whether you use what we're going to learn today and tomorrow, or what we're going to get to on Wednesday, which is law of cosines. If I give you 2 angles and a side, that's one of the kinds of problems you can solve with what we're learning today. Now, even within that, there's actually 2 ways I can do that. I can give you 2 angles and a side. I can give you 2 angles and tell you the side that connects them, that's between. Or I can give you 2 angles and give you the side that's not between. Okay? And here's a picture of each case. With the one on the left, you've got 2 angles, and then the side that you're given connects the 2 angles. It's between them. The one on the right, you're given 2 angles, and this time the side that you're given is not the one that's between them. The one that's between is on the bottom. They didn't tell me that one. They told me another one. All right, so both of those cases, to solve them and find all the other sides and angles, you would use law of sines. So that's one case. And the second case is if I give you 2 sides and an angle. Specifically, it has to be like that. Because there is another way I could give you two sides and an angle. I could do this. SAS. But the problem with that is we can't solve it with what we're learning today and tomorrow. You can solve SAS, but that's going to come up on Wednesday. So if I want to give you two sides and an angle, and I want you to solve it with what we're learning today, I have to do it like this. Two sides and an angle that is not between the sides. Okay. In this problem, the angle that's between the sides would be right there. I cannot give you that one and have you solve it today or tomorrow. Okay, what I could have done is I give you this one, or I could give you that one. Either way, that would be two sides and an angle that's not between the sides. Okay, so any question on those three? Sometimes you see these words like when you're doing proofs in geometry. We're just using them to describe the kind of triangle that you're given. So eventually what you might want on a reference sheet is a list. The types of problems that you use for law of sines and the types of problems you use for law of cosines. These are the three for law of sines. Okay. And that's what I just told you. These are the three types that we use the law of sines for. Okay, so what I'm going to do now is I'm going to show you kind of where the law of sines comes from. It's almost like a shortcut. You could definitely solve problems without the law of sines. It would be longer. But once we figure out what the law of sines is, it's a shortcut. Okay. And that's what I'm going to show you right now. So what I've done is I've drawn a triangle. Okay, I tried to make it so none of the sides look the same length. So that's just a scalene triangle. I'm not going to need all the sides and angles to do this, so I only labeled two sides and two angles. I don't need the third side and the third angle for what I'm going to do. But the first thing I did is I put in a perpendicular line from one of the vertices straight down to the other side. So by doing that, what did I just create? I had a big triangle, and I just created what? Yeah. I just created two right triangles. So what I've done is I've kind of turned this back into a problem we could have done a couple weeks ago. I'm turning it into right triangles. And if that's a right angle, then that is too. I'm going to look at each triangle separate. So this I'm just going to call H, because it's the height of the big triangle. I don't want you to get it confused with hypotenuse. So maybe H isn't the best letter, but H, it's the height. So that's the letter I'm going to use. All right, so for now, let's block the right-hand side. Okay, just going to look at the left. And I've got three pieces of information that are labeled: alpha, H, and B. Okay. My goal right now is to come up with a formula for H. Okay. I want to be able to figure out what's the height of that triangle. All right, so I'm going to look at the names of the two sides that I have, okay, from the perspective of alpha. What's the name of the side that's farthest away? We've labeled it H, but we have another word we can use to describe it. Joe? So our choices are going to be opposite, adjacent, or hypotenuse.
Oh, no.
Yeah, it would be opposite. Yeah. So I know what you're meaning when you talk about A, because in the big triangle, A is across from alpha and B is across from beta. But for now, we're just looking at this small triangle. So A is part of the other triangle that we're not looking at yet. So Joe said that would be opposite. And Christian, how about the side that's across from the 90?
The adjacent?
No, not adjacent. What's the side that's always across from the 90?
Hypotenuse.
Hypotenuse. Side across from the 90 is always the hypotenuse. Right? Opposite adjacent are always the sides that are not the hypotenuse. So we've got opposite and hypotenuse. What trig function has those two in it? Yep. Sine. So I'm going to write down sine of alpha equals, sine is opposite over hypotenuse, h over b. Now, I want to get h by itself. So how would I move the b to the other side? So,
You would multiply it on both sides.
yep, you multiply both sides by b, so you get b sine alpha equals h. Now, if we knew b and we knew alpha, we could just use our calculator, plug them in, and find the height of that triangle. So I'll come back to that in a second, but I'm just going to call that box 1. Okay, box 1 gives me a formula for the height. Any questions on how we got box 1? All right, now I'm going to do the same thing again, except now I'm going to cover up the left-hand side, and I'm going to look at just the right. Okay. I want to come up with a formula for the height. Again, we'll do the same thing. Right? But this time I've got different pieces of information. B, the same H, and A. Right, so let's figure out the names of the two sides we have this time. So H, from the perspective of my angle that I've circled, what side is H? Oh, Eric?
The height.
It's the height, and from the perspective of beta, what would you name it?
Opposite.
It's opposite. And how about A? What side is that?
Adjacent.
No, not adjacent, because it's across from a 90. Hypotenuse. When a side is across from a 90, it's always hypotenuse. There's no way around it. Across from 90, hypotenuse. So I have opposite and hypotenuse. What trig function is that? Oh, Oscar. What trig function is that?
Opposite and hypotenuse. Cosine.
No, cosine is adjacent and hypotenuse.
Oh, it's
Sine. Yeah, it's the same one we just did. Sine is opposite over hypotenuse. So could someone set up my equation for me? What I would write this time. Yep.
Sine of beta equals h over a.
All right. So sine of beta equals h over a. Now I want to get h by itself again. So how would I do that? Yep.
Multiply a by the left side and the right side.
And on the right, multiply both sides by a. And there's a formula for h. Another formula. Same h that we just had before, but a different formula. So box 1 gives me a formula for h. Box 2 gives me a different formula for h. What does that mean? If box 1 gives me a formula for h and box 2 gives me a formula for h. Yeah?
That means that I don't have this in like nice terms, but like it's saying that pretty much no matter how much you go up by beta or alpha, you're gonna go down by alpha by A or B. So like you should get what I mean.
So I'm kind of thinking like if you could come up with another fact there. So we've got one fact, we've got a second fact, but there's a third fact based on the two you have right there. You're kind of like a detective, and you knew the first fact and you knew the second fact. What would be the third thing you could automatically say here? Yep.
The equations are equal.
Can you be more specific?
B sine of alpha is equal to a sine of beta.
Yeah. Box 1 equals box 2, right? Since they're both equal to h, then they must be equal to each other. So now I can write this. Box 1 equals box 2. So let's write that. B sine alpha has to equal A sine beta. Now what I'd like to do is write this so that the A is over on the same side as the alpha, and the B is over on the same side as the beta. So how could I move A to the left side? Divide. So let's divide by A. And how could I move B over to the right side? Divide by B. So if I divide both sides by AB, the A's cancel out there, the B's cancel out there, and what I'm left with is sine of alpha over A equals sine of beta over B. And that is the law of sines. Right? So really the law of sines comes from right triangle trig. Right? It's just that once we have the law, we're not going to have to go back and think about it as a right triangle. All we're going to do each time is use this formula. Sine of alpha over A equals sine of beta over B. And there's a third part, which we didn't really go through the proof of. But does anyone have a guess what the third part would be? Yeah, kind of showed you, but yeah.
Sine of gamma over C.
Sine of gamma over C. So sine of alpha over A, sine of beta over B, sine of gamma over C. If you wanted to show the third part, you could take the same triangle we just did, and instead of using the sides A and B and alpha and beta, do it from a different angle. Maybe use A and C and alpha and gamma, okay, and draw the height in a different way instead of the way I did it. So that's the law of sines. Now, whenever we use this law, I consider it in its three parts. First part, second part, third part. You only use two parts at a time. Okay? So whenever you're setting something up, you're going to use the first two, the last two, or the first and the last. And as I said earlier, it is not necessary to even know this law. Okay? If you gave me a problem and you asked me to figure out like all the sides and the angles, and let's say this was 10 and this was 3, and you said, all right, I want you to figure out, the height of that triangle, or you want me to figure out something else. Well, I could think of it like that. I could draw in my height, and then I could use right triangle trig on this side and find height. And you'd have to give me something else, like maybe that's 10. And then I could use right triangle trig again. I could find the length of this part. I could have the length of this part. And then I could just add the two together to find the length of the bottom. Okay? I can do it that way. So I don't actually need the law of sines. But that's going to take me longer. Okay? If I wanted to do the length of the bottom this way, now I'm doing two problems when I could just do the law of sines and do it in one problem. All right? So it is a nice shortcut. The way we'll solve the triangles is pretty much the way we did a couple weeks ago. We'll make a sketch. It's kind of helpful to just see what's across from what. And then we'll put all the information we want to find in a table. 3 sides in one column, 3 angles in the other. What I generally do is I'll put a box around what we need to find so we can kind of remember what was given and what we have to find. Okay, so remember, all the angles still add up to 180, but you cannot use Pythagorean theorem to solve anymore, okay, because that is only for right triangles. If for some reason you get a problem this week that does have a 90, then yeah, go ahead and use Pythagorean theorem. But most problems this week will not have a right angle. Okay, so as far as kind of the explanation, that's it. So we'll just look at a few different examples. Okay, I'll probably go through one of each case. So we had three cases I gave you in the notes. Let's figure out which case this one is. All right, so we've got a bunch of information. I've already started putting it in a table. What's the other thing I said we want to do besides make a table? Yeah, let's make a sketch, and that's going to tell us whether we have Angle, side angle, angle, or side angle. So let's make our sketch. Okay, remember you can label it any way you want, as long as you put A across from alpha, put B across from beta, and then put C across from gamma. Okay, so now if you look at the information you have, they've given me two angles and a side. Did they give me the side that's between the two angles? Or did they give me the side that's not between the two angles?
Not.
It's not. C is the side that's between the two angles. So this problem is this one. It's where they gave you a side that's not the one connecting the two angles. So you can write side angle or angle side. As long as you recognize that it's that type, then you're like, okay, that's one I use the law of sines for. Right? If it wasn't that type, maybe we'd be using the law of cosines. Okay? But this falls under law of sines.
Couldn't you just look at like the angles up top and be like that's side angle because there's two angles on the side? Or do you have to actually draw it?
As long as you can recognize that it's two angles and a side, because that's also two angles and a side, but it's not the same type as the one we're going to do right now. This is the one where the side is between the two angles. So that's angle, side, angle, which still is law of sines. So really, anytime you're given two angles, it's a law of sines problem. Okay. Anybody see something I can find here right away? Probably could have found this without anything I showed you so far. Yeah?
The third angle.
Yep. What's the name of the third angle?
Gamma.
Gamma. And how much is it?
80 degrees.
80 degrees. So out of the three things we got to find, there's one of them. Now, a couple weeks ago, what did I say about using that angle to do more stuff in the problem? Yep.
Not to because it wasn't a given, so it could be wrong.
Right. I said once you calculate something, don't use it because it wasn't a given. If you use it and you got it wrong, you're going to get other things wrong. And that worked fine when we had right angles, where we could do that. This week, we're not going to be able to do that. So in order to find C, I'm going to have to use gamma, which means if I got gamma wrong, I'm going to automatically get C wrong as well. I could still get B right. B has nothing to do with gamma. All right. Kind of think of each row as its own separate thing. All right. So gamma is going to affect how you get C. Beta is going to affect how you get B. All right. So just be careful that you get gamma right. And now at this point, there's no order you have to follow for this problem. You can find B or you can find C. Let's do B first. So I'm going to find B. So when you use law of sines, you always have to pick a row that has everything in it. Right? So the only row that I have that has everything in it is the top row. Right? Alpha is 40 and A is 4. So fill those two pieces of information in to that part of the formula. Alpha is 40 and A was 4. Okay, so we're going to have sine 40 over 4 equals, and now if we're going to find B, we're going to use the part of the law of sines that has B. For now, I'm not going to use the third part. I will after, but just to find B, no, I don't need the third part yet. So we're going to put sine of beta over B. So sine of 60 over B. And if you set this up correctly, you've got 4 spots. 3 of them should be numbers. Only one of them should be a letter. And now we solve it. Okay, so that's a proportion. Right? Just like having something like this. How do you solve a proportion? Yeah,
Cross multiply.
you cross multiply. So we're going to do exactly the same thing right here. So we're going to do 4 times the sine of 60, and I'm not actually going to write that answer out. I'm just going to leave it just the way I said it. 4 times the sine of 60 equals b times the sine of 40. So you shouldn't use a calculator for any of these problems until the very last step. All right, so I cross multiplied. But now I want to get b by itself. So what do I have to move to the other side? And how would I move it? Joe?
Divide by sine of 40 on both sides.
Yeah, this is just like having 4 times 8 equals 2 times x. If you want to get rid of the number that's being multiplied by the thing you don't know, divide by the number that's right next to it. So like Joe said, divide by sine 40. Divide by sine 40, and divide by sine 40, and that's what we're going to type into the calculator. So I'm never actually going to know what the sine of 60 is or what the sine of 40 is. I'm going to type it all in at once and just hit enter and get the final answer. All right, let's do this. What do I want to double check on my calculator first? Yeah, I got to make sure I'm in degrees. All problems this week are in degrees. All right, so 4 sine 60, close parenthesis, divided by sine 40. Okay, so I get 5.389 for B. Now, before I go any further, I just want to show you a few ways you can mess up typing that in. Okay, one thing you could do is you could forget a parenthesis there. If you forget that parenthesis, you're going to get a different answer that's totally wrong. Okay, that's doing, what you're seeing right there is actually doing this. 4 sine 60 over sine 40. That's not what you were looking for. All right, you didn't want to have sine inside the sine function. All right, so you don't want that. The other thing you could have done wrong here is if you left it in radians. That would make your answer come out wrong. Another thing you could do that's not wrong, but it's going to mess up your accuracy, is type each one of these in and round them as you go. Not a good idea. So let's say you wanted to do this calculation, and you said, all right, I'm going to just find the sine of 60 first and call it 0.87. All right, so let's call that 0.87 times 4, and then I'm going to divide by sine 40. So let's just do the sine of 40 separate, and let's round that off, 0.64. All right, now let's take 4 times 0.87, and that's 3.48, divided by 0.64, and I get 5.44. That's not what I got there. 5.44 and 5.38, they're not super close. 5.389, 5.388, okay, that's close. It's within 1/1000. But if you're like more than 1/10 off, you shouldn't be. Because we're going to round to 3 decimal places, so you should at least be accurate to the 100th. Maybe your 1000th place would be a little different, but not the 10th place. All right? So don't round as you go because of what I just showed you. All right. All right, last thing I want to do now is find C. I've got A and I've got B. Can I do Pythagorean theorem to get C?
You could, but I don't think you should.
All right, so you think I can, but I shouldn't. All right, any other thoughts? Yeah?
No, because it's not a right triangle.
Yeah, you can't because it's not a right triangle. If you use Pythagorean theorem, you're assuming gamma's 90. Gamma's 80. So C would come out wrong. All right. So I see what you were thinking of. If, the kind of problems we talked about last week, don't use what you found to find other things. That would be another issue. But in this problem, you can't even use it. All right. So now, one thing I can tell you is that gamma is the biggest angle, so C should be the biggest side. Okay. It's got to be bigger than 5.389. But it can't be too big. When you add up A and B, those have to be bigger than the third side. So it's got to be bigger than 5.389, but it can't be bigger than 9.389. Okay? C can't be 50, but that's way too big. So I'm looking for an answer between 5.3 and 9.3. Exactly what? I don't know. That's what I'm going to find right now. Okay, so let's find C. So whenever you use the law of sines, I said always use a row that has everything in it. Well, now you've got options. You've got two rows with everything in it. Which row should I use? Row A or row B? Yeah? How come?
Just because it's neater next time.
Because it's neater? All right, so there's no decimals in it. I like that fact that there's no decimals. What's another good reason for using row A? Yeah.
It's the original numbers.
It's the original numbers that were given to you. We know they're right.
All right.
So let's start setting it up to find C, exactly like we did B. Sine of 40 over 4. Except this time, don't use the middle part for the law of sines. We're going to use the end part, sine of gamma over C. Okay, so anyone think they can tell me what I'm going to fill in on the top? Sine of 80. Well, I know we calculated it, and I kind of warned you about doing that, but you've got to use it. There's no way around it. So sine of 80 over, what goes in the bottom? C. Oops. Okay, so now we're going to cross multiply. I'm not really super concerned if you show the cross multiply step. I usually don't show this step in the middle. I just look at it and I say, okay, C is going to be 4 times the sine of 80. But then I'm going to have to divide by sine 40. It's exactly what I just did up above without showing the middle step. Okay? I would have 4 sine 80 equals C sine 40. But then I would have to divide by the number next to C. If you want to show out that middle step, that's fine. Any questions on that?
Yeah, I get that.
So I just did the cross multiply. 4 sine 80 equals C sine 40.
Yeah.
But I have C sine 40, so I have to divide by the sine of 40 to get C by itself. Now don't try to simplify that. Don't try to say, oh, 80 divided by 40, it's 2. You can't do that. Just type the whole thing in. So we've got 4 sine 80. Make sure you close the parenthesis. Divided by sine 40. So I said we were looking for an answer between, I think, 5.3 and 9.3, and we got one. So it seems reasonable as long as I didn't make any mistakes. 6.128. Okay, again, if you had 6.129, 6.127, that's fine. If you had like 6.3, well, when your calculations are going out to the thousandths and you're a tenth off, it's kind of like if you were machining something and your accuracy was supposed to be the nearest thousandth and you were like a tenth off, it's kind of a lot. It's like hundreds of times over your error you should have been. Okay? So that's where you should be. Any questions on that? Yeah, that's pretty much how you solve law of sines problems. They're all pretty much like that. Let's look at this one.
Good, bro.
So this time they've given us the diagram, and what kind of triangle is that one? Yeah, it's angle, side, angle. So we'll take a look at how to solve that one with angle, side, with law of sines. Okay, so this is angle, side, angle, which still falls under law of sines. Well, one problem we have here is I said to use law of sines, you always have to have a row with everything in it. Well, if you look back at the last problem, they started you off with a row with everything in it. We've got a problem here. We don't have a row with everything in it. But is there something I could find that would allow me to have a row with everything in it? Because if I can't get a row with everything in it, then law of sines isn't going to work for me. Joe?
You would find C.
So I've got C.
C, I mean like you find gamma. But
Gamma,
you use
okay.
C.
Yep, so we're going to find gamma. Do we need to use C to find gamma?
No, I was just saying that you would find a row of C.
The row of C. Oh, I got you. Yep. So, yep, perfect. We're going to find gamma. What's gamma going to be here?
95.
95. Okay. Now we've got a row with everything in it. Now, this time, it's even more important that we get gamma right, like the first angle that we find, than it was in the last problem. Okay, the last problem I told you it was important to get gamma right, because you're going to use it to find C. Well, this time, you're going to use the last row to find A, and you're going to use the last row to find B. It's the only row that's complete, so you're going to have to use it twice. So what does that mean if you got gamma wrong?
You would get everything wrong.
In this problem, if gamma is wrong, it's all wrong. Yeah. And there is no way around that. The only kind of quick visual checks I can do in my head is alpha and beta are pretty close. So A and B are going to be pretty close. But which side is going to be a little bigger? A. A should be a little bit bigger than B. Okay, not a lot, but a little bit. Now, which angle or which side we find first doesn't matter. So let's find A. Okay, let's start with the information that we know. Can somebody tell me how we're going to plug in the row that I know into the law of sines? What should I start with? Yep. So sine 95 over 4. It does not matter which side you put it on. Put it on the left, put it on the right. Doesn't matter. And then what did you say on the other side?
Sine 45 over A.
Yep, sine 45 over A. Okay, and then once I cross multiply, can somebody tell me what I'll have for A? I don't need the decimal, just what times what divided by what. What am I going to put into the calculator?
4 sine 45 over sine 95.
Yep. That's it. And now we take that in. Okay, let's see what we got. So we get 4 sine 45 divided by sine 95. Okay, 2.839. And I know there's no error there from rounding because I didn't round anything off in that problem till just now. Okay, so that's as accurate as I can be to 3 decimal places, you know, for now. So 2.839. All right, now that I know A, I've got a few thoughts about B. Well, it's got to be a little smaller than 2.839, okay? But it can't be too small because when I add A and B together, they have to be bigger than the third side. So like if B came out to 0.5, that's too small. Because A plus 0.5 is not bigger than 4. So B has to be at least about 1.2, a little less than 1.2 at a minimum, and at a maximum about 2.8. Right, so maybe it's going to come out, I'm just going to guess, around 2.5, somewhere around there. Let's see what happens. So find B. Okay, I've got the same choice I had last time with this step. 2 rows that are full. Which row should I use to find B?
C.
Yep, we're going to use C. We've already mentioned Y. Okay, so stick with row C. Sine 95 over 4. Set it up just like we did before. You're just changing one number. That's all we're going to change. So these kind of problems, they feel kind of repetitive because you are doing the same thing over and over. That's why this kind of thing is very easy to do on a computer, to set up a program where you just type numbers in, you hit enter, and it just spits the answer out. Because the calculation, it's the same thing over and over, and computers are good at doing the same thing over and over. Yeah. Yep. And then on the other side, sine 40 over B. Okay, and when I get B by itself, Ephraim, can you tell me what my formula will be for B?
4 sine 40.
Yep, 4 sine 40
And sine 95.
over sine 95. So what's nice, since I typed in pretty much the same thing except I changed one number, on my calculator I can hit second, enter, it'll bring up the last thing I typed in, and all I have to do is change one number. Is that faster than typing it in from scratch? I don't know, maybe, but it's kind of handy. And I thought it'd be about 2.5. I was a little off. It's 2.6, but if we round it properly, it's 2.581. So you could almost use Pythagorean theorem on this problem, because gamma is almost a right angle. But, again, it's almost a right angle, so if you use Pythagorean theorem, you would almost get the problem right.
Can you scroll up a little bit? No.
Yeah. But almost getting the problem right means you got it wrong. So don't use Pythagorean theorem unless you got it 90. Okay. Any questions on those two types? Okay, so both of those types, you get 2 angles and a side to start. Okay, last type. So the last type, they're starting me off with 2 sides and an angle. Out of every case we studied this week, this one is the most annoying one because of something that can happen. When you're solving this kind of problem, it could end up being one solution, just like the problems we've done in class so far. Or it could end up being a 2-solution problem, which isn't really harder, it's longer. You got to do everything twice. Okay? Or the fastest case is when it's no solution. You pretty much realize it's no solution right away, and you're done. You can't solve anything in the problem. So this is the only case that can happen. It can never happen in angle side angle. It can never happen in side angle angle. It can never happen in the 2 cases we're going to learn on Wednesday for law of cosines. It can only happen here, side angle. Okay, and the way I remember it, well, if you look at the abbreviation for it, if you write it backwards, then this case can be a pain in the, there you go. All right, so that's how I remember that this case is the one that's kind of a pain, SSA. So we'll start it, we'll go through it, and then when we get to the point where we got to kind of figure out, wait a minute, 1 solution, 2 solution, what's going on, I'll explain how we do that. So I've taken the information that I just gave you up above and I put it in a table. And I think by putting it in a table, you should recognize something here that's different. Does anybody see what's different about that table compared to the other 2 problems we did?
We don't have C.
We don't have C, okay. What else? Just kind of like big picture, just forgetting like what the things are called, just look at like where the things are we know and where the things are we don't know. Yeah.
You don't have two angles, you can't solve for the third one.
Right, we don't have two angles, so we can't solve for the third one like we did in the last problem. Also, we have a row that's completely empty. Whenever you have a row that's completely empty, and you have no way to find anything in that row directly, that's another hint that this is the case. You got to be careful. Okay. Each problem, we might have started off with a row that was empty, but we were able to find something directly using other information. In this problem, you cannot find C directly, and you cannot find gamma directly. This problem has a certain order you have to go in to solve. You cannot go out of this order. You have to find beta first. Pretend that the last row doesn't even exist right now. It's useless. There's no information in it. If you try to use it, you're going to be missing two things at the same time. You can't solve a problem where you're missing two things at the same time. So row 1 looks good to me. It's got everything in it. Row 2, that looks good to me because it's only missing one thing. Okay, so I can set up my law of signs to find beta. Okay. Okay, and Kiara, can you tell me what would go on the left?
Side 40 for
Sine of 40 over.
is it 4?
Well, this one doesn't have a 4 in it, so we're not, nope, not 4.
Oh,
But I like the 40 in the top.
that's a
3, yeah. Sine of 40 over 3 equals. And then, how about, Christian, can you tell me what's going to go on the other side?
Would it be sine of beta over 2?
2, yep. And we're going to start to solve it, just like we always do. Let's cross multiply. 3 sine beta equals 2 sine 40. Now my goal is to get beta alone. So Corey, what's one thing that's on the left-hand side that I could move over to the right?
The 3.
The 3. And how would you move that over?
Divide.
Yep.
Also.
So divide by 3. And now I just have this. 2 sine 40 over 3. What's still on the left-hand side that I want to get rid of?
Or sine.
Sine. Sine is a function. It's not a letter, it's not a number. So you can't add, subtract, multiply, or divide to get rid of a function. The only way to get rid of a function is with another function that cancels it out. Like square, square root. They cancel each other out. Sine, something, cancels out sine.
Inverse.
Inverse sine. Yep. So we have to take the inverse sine of what's on the left. Take the inverse sine of what's on the right. Inverse sine, regular sine, cancel each other out. And I did not multiply by inverse sine. Okay. Same thing here, if you have this. You wouldn't say to someone, multiply each side by the square root. No. You can multiply by letters, you can multiply by numbers. You can't multiply by square root. You can take the square root. That's the word you want to say. Take. Same thing here. Take the inverse sine of both sides. So we get beta equals, and now I'm going to type all that into my calculator. Yep.
Why don't you do regular equals?
Because it's going to be an approximate answer. I'm going to round it to a decimal right now. So 2 sine 40, close parenthesis, divide by 3, close parenthesis again for my inverse sine. So what my calculator does is it types it in like this. I don't need the extra set of parentheses around the 40, but I can't stop the calculator from putting it in, so that's just how it does it. Now, I know this is not a no solution problem, because if it was no solution, I wouldn't have gotten this number right there. So 25.374 is definitely a solution. I wrote it up higher in the box in case there's a second answer. I'll just put it down lower in the box. And then what I'll do is I'll call the first one beta 1 and the second one beta 2. Only if there's a second solution. I'm going to check right now to see if there is one. Right, so I put it up here, 25.374. You can put it there if you want to. Doesn't matter. All right, so you have to know what to do. There's arithmetic you got to do with 25.374 to get the second solution. Let me show you two answers, two different angles that have the same sign. Okay? Let's do the sine of, I'm just going to pick easy numbers, sine of 30 and the sine of 150. Okay? What we had in our problem, we had the 0.5. It wasn't 0.5, but that's basically what we had. We had this number. You did inverse sine, and you worked backwards to figure out the angle. Even though these have the same value, when I do inverse sine of 30, or inverse sine of 0.5, the calculator only gives me the 30. It didn't give me the other answer. So I'm hoping you start to see a pattern where if 30 is one of the answers, what you can do with it to get the other answer. Right? Let me do another one. Sine of 10, sine of 170. Same answers. But if you type inverse sine of 0.1736, the calculator is only going to give me 10. It won't give me the other one. So does anyone see, if you know 10 is an answer, how you get the other one? Anyone see the pattern? Yeah?
It works in from the 180.
Yeah.
So like if it's 170, it would be 10 because that's 10 away from 0 and it's 10 away from 180.
Yeah, see basically once you have one answer, you subtract it from 180, and that's the second answer. And that's what I wrote right here. So to check if there is a second answer, take 180 minus what you just solved for. Okay, in our problem, I think it was beta, but you might solve for alpha first, you might solve for gamma, it depends on the problem. But in general, 180 minus the answer you just got. Okay, well, let's do that first. Okay, 180 minus 25.374. So if there is a second answer to this problem, it's 154.626. Okay, let me scroll back up and let me look at what they gave me. Okay, I'm not going to write that in the box yet. Just going to put it off to the side with a question mark and ask myself, okay, if there's a second answer, it's 154. Is it possible, and that's what I wrote next, is it possible to have the answer I just got, 154.626, and the angle they gave me in the same triangle? So let's go back up and look at the angle that they gave me. What angle did they give me to start this problem? They gave me a 40. So would a 40 and a 154 fit in the same triangle? Joe, what do you think?
It would equal 194, which would, and then blah blah blah, but it would be over 180.
It's over 180.
Can't let's try the triangles.
So because the angle they gave me was 40, and the second answer, if it worked, was 154, the second answer is too big. Okay, the second answer is too big, which means it doesn't work. And that's what I go through right here. So I did 180 minus the 25.4, and you get 154.626. But we were given a 40-degree angle to start with, and if you add 154 and 40, this is all what Joe just said, if you add those up, it's 194. It's too big. The other answer is too big. So, yeah. So what this means is it's pretty much all or nothing. Either everything has a second answer, everything has just one answer, or everything has no answer. Well, it's not a no answer problem, because I already got an answer for beta. But the second answer didn't work for beta, which means the second answer doesn't work for gamma, the second answer doesn't work for C. This is a one solution problem. So from this point, it's just like the previous two problems. If the second answer had worked for beta, what I would be doing right now is this. I would say, okay, I got two answers for beta. I'm going to get two answers for gamma.
You have to find the second answer or not.
And I would be getting two answers for C. So I would basically be doing this right now. I'm getting both answers for everything. But since I know the second answer doesn't work for beta, don't have to worry about it. Don't have to worry about it. Don't have to worry about it.
If it did work, would you have to find it for A, B, and alpha too?
No. If there's a second answer, it's only for the stuff you have to find. It's not for the stuff that was given. Okay. It would just be for the stuff that you have to find. But again, we're good on this one, so now we don't have to worry about the second answer.
Isn't it more likely that there will be two different solutions if it's closer to 90?
It depends on what the other side is. So it's kind of a combination of what is the side they gave you and what's the angle they gave you. It depends. Yeah. All right. So now that I've got beta, what's the next thing I could find in this problem?
Get a side.
I can't get a side yet.
Yeah.
I can get gamma. How would I get gamma?
And
Joe?
You would add the two angles together and then subtract them from 180.
Yeah. Now I got 2 out of 3 angles. Just add them up and subtract from 180. All right. So if I add those up, I get 65.374. So that means gamma is 114.626. And that's the second thing I can find. Now I finally have a piece of information in the last row, so the last row isn't useless anymore, which will allow me to find C. All right. So you have to do it pretty much in that order. All right, so let's set up my law of sines one more time, just like I did to start. I'm going to use sine 40 over 3. Sine 40 over 3 equals sine 114 over C. 626. Sine 114, 626 over C. Okay, so once I do my cross multiplying out, what am I going to type into the calculator to get C? Yep, Corey?
3 sine parentheses 40 divided by.
Well, sine,
Oh.
3 sine 114.626.
Oh, okay. And then 3 sine. No.
Joe?
Sine 40.
Sine 40, right? 3 times sine 114, 626, and then you divide by the sine 40. Yeah. All right, so let's look at it and see what we should get. What's the biggest that my side could be when I type all that in?
5.
Can't be, yeah, 5 is a limit. Can't even be 5. It's going to be like 4.9. So it's got to be less than 5. But how small can it be at the smallest?
3.
It's got to be bigger than 3. Yeah. So the answer here has got to be between 3 and 5. Let's type it in and see what we got. So we've got 3 sine 114.626 divided by sine, what was it, 40? Sine 40. That's exactly what we said it had to be between. It's 4.243. So just put that right there. So on the test this week, there's not going to be as many problems as usual because these problems take a little longer. There'll probably be 6 questions, but each question will have 3 parts. So it'll be like I'm looking for 18 answers on the test. Like this would be 3 separate answers. And if you get one right and another one wrong, you get credit for each answer you get separate. So any questions on that? So that's law of sines. I know some people were still copying. Is anyone still copying down the directions to find the second answer and how we know it didn't work? So tomorrow, what we'll do is we're going to look at 2 more cases. Okay, both sine angle side. I'm sorry, both law of sines. But we're going to look at the case where the second solution works. So we'll go through that. And then we'll look at the case where nothing works. Okay, we try to solve the problem and we can't do it. So those are going to be the only 2 non-word problems. And then I think tomorrow we'll also do 2-word problems. All right, so homework. Tonight, this week, we're back in the book. There's no worksheets or I don't have any handouts this week until the review day. I'll have a handout for that. Okay, but the homework tonight is on page 266, and it's all odds: 9 through 13, 17 through 21, and 25. Okay, we've got just a little under 15 minutes. So please use the time to try to get started on it, or if you read the directions over, you don't understand it, just let me know, and I'll try to clarify it. But it's directions are written pretty much exactly like we did in the notes. And don't forget this Friday, last week of the term. So if you got to finish up anything, this is it. Okay, this is for you guys. This is the halfway point in the class. And in terms of tests. After this week, you'll have already taken more than half the tests in the class because we only have 9 academic weeks of material that I test you on. This is the 5th one. So you'll have done 5 out of 9. Next term, there's 4 weeks of material, and the last week is the final. We don't do anything new. So in terms of material, you're actually more than halfway done after this week.
Can we take a midterm?
There is no midterm. Nope, your midterm is the same time everyone takes finals.
Alright.
Yep.